So we just came back from parent-teacher conferences, and we got to meet our daughter's teacher.
Preschool teacher.
And she was so annoying. Like,
she's nice.
She's a preschool teacher.
So this evening, I am going to be interviewing John. Just asking him a few questions. So, my first one should be, why do you fidget so darn much?
Can I have the previous one? I won't fidget with the previous.
So my first question, you will totally fidget, is what is it that you love so much about concrete? There have been a number of times where I've evaluated if concrete or I were your first love. I feel like you have dialed in me being your first love, but you definitely, thank you for that, I appreciate that. But there's just, what is it that you love so much about it?
The simplicity. You know, I was never much of a smart kid. My parents will tell you, and I'm sure they had, that I had a lot of potential in school, but I just never understood school very much. There was never anything that really made me drawn to, besides hanging out with friends and meeting women and what? No, that was why I went to school. Hey, at least I went.
Get with the ladies.
Get with the ladies. At least I went. It was until I started working with concrete at a very practical level. It's an amazing material that mimics what Mother Nature can do. You start off with raw ingredients, and with the simplest of equipment, you can create a plastic material that can fit into any shape, any color. You can apply different artistic means and methods to shape it and make it look pretty or functional. At a very small scale, there are people who have studied this for thousands of years, thousands.
Probably not individual people, but there are
groups,
thousands of years of research.
Thank you.
Of concrete.
Groups of people, and we still don't truly understand the material. What's the matter?
It's just like unfocused right now. It's fine.
It just, we don't fully understand it. It's like that quote from Lord of the Rings, You can hang out with a hobbit for 100 years and they'll still...
surprise you.
Something like that. Same thing with concrete. I like that there's always a mystery. I like that there's simplicity to it. And for me, as coming from a family of students, both of my parents were teachers. Both of my sisters were awesome at school. I was not the black sheep, but the kid who didn't like school. Concrete actually helped me appreciate, the academic environment.
Sure.
I wanted to be able to learn more, not just for the sake of learning, but to manipulate this material. So it's not just the material, it's how the material makes me want to be a smarter person. Because our altruistic mission and vision for our company that Whitney and I put together was to save the world with all the concrete in it. My goal for my occupation was to be one of the leading experts for concrete in the world one day.
Right.
And it's because I want to make concrete better, save the world with all the concrete in it. And it's because of this material that I've gone through school, degree after degree,
right,
and constantly educating myself. So I think that's why I love it. I don't know if that's the answer you were looking for, but
I just was looking for an answer. You even surprised me a little bit with that, so thank you. What's your favorite class you've taken through your for your concrete
my
education?
tenure? Oh, there's a few of them.
I know you really liked Dr. Esche.
Professor Esche.
Yeah.
Sven Esche.
Sven
Esche.
Boy, you had some great instructors.
Mechanical engineering professor. Can I do top 3 classes?
Yeah, sure.
Top 3 classes. In no particular order. I'm getting the finger. Sorry, I'm trying. In no particular order. Number 1 that I'll start with was mechanical engineering class, advanced mechanical engineering, structural engineering.
Is that Sven?
That was Sven, Professor Esche. And he loved the basics. He loved how the basics built on each other to help you with the more advanced problems. And he would ask us questions like, what is Saint Venant's principle? And, you know, I used to, you know, I loved his classes and the books he chose, and
Right.
his homework problems. So I hung on every word, answered every single problem, even if I was wrong. And he would always yell at me. He goes, "Mr. Belkowitz, you cannot answer this question." And he would yell, and it was all graduate classes. He would yell at the graduate students because he would ask them this question. You should answer this question at 3 o'clock in the morning. If you can't answer this question, I'll take away your bachelor's degree. And he would keep doing this and this and this on it. And Saint Venant's principle, or the one he was referring to, and you know, don't quote me if I'm wrong on this, but the closer you are to a load or applied load, the more you're going to feel that applied load. And it was like him banging on the desk. And these students were very far away from him at a certain point, and then we get closer, he would bang on the desk. So in a way, he was trying to express Saint Venant's principle. He was a very practical, brilliant mechanical engineer. So that was number one. Number two is Yong Bo Yi.
Yeah, loved him.
Mathematics,
Yeah.
advanced elasticity.
Jeez, that was it.
And it was the first class that Whitney, I'm talking to you, Whitney ever came to me with, or with, you came
Yeah.
with.
I don't know why. I just wanted to hang out all
I
the
missed
time, I
you
think.
and wanted to hang out with you, yeah. So
And he was nice, so.
Professor Yong Bo Yi was teaching advanced elasticity, and it was pure mathematics. Boundary conditions, wave propagation, the deformation of materials, and Whitney and the mathematics.
It was just like acrobatics.
It
with
was-
calculus, like hardcore.
It was well beyond me, and I hung on every single word. You know, there's a teacher's triangle, right? So this is the front of the classroom. There's a teacher's triangle where the teacher is going to be able to pay attention to the first person at the tip of that triangle, and then everybody else within that triangle, that reach. And as you go toward the back, you get less of the energy from that instructor. So with Yong Bo Yi, I sat in the middle, front and center, every day, back straight, notebook out, chapter open, that we were just hung on every single word because I wanted to get what he had. That passion for mathematics, to use it to understand a different side of the material. And that's why I loved his class, because he helped me understand the models and algorithms that we use in our simulations. We're trying to represent some physical phenomena in nature, in our construction material. Our final project was we had to model the deformation of the St. Louis Arch.
Oh, that's cool.
And I said, is there any way I could pretend that the St. Louis Arch is made of concrete? And see if I can do the derivations, the integration. And to him it doesn't matter, it's still a material property.
But you...
Sure, pretend it's concrete. And it was that time that Whitney came with me to this class, and he asked Whitney, you gotta remember this is Chinese gentleman, barely, he spoke the language, not very well, very quiet. Brilliant man. And Whitney said, he asked Whitney, do you like math?
Did not care for it back then at all.
And what did you say? Yeah, you didn't.
He was like, I hate math.
And he was like, what do you mean you hate math? Math is in art. Math is in nature. Math is everywhere. Math is life. And he went into all these derivations. Excuse me, I'm so excited. He went into all these derivations of how math is used to represent life.
Right.
And I mean, talk about seeing somebody. I mean, I'm passionate about concrete.
Sure.
That guy was passionate about math.
Yeah.
And that's why he's my number 2.
Yeah.
That class.
Yeah.
Number 2. My third one, I'm going to be a little bit egotistical. My favorite class, number 3, is the class that I taught.
Oh, reinforced concrete. I
Now,
agree.
I probably will never get the chance to be a professor again. I was lucky. I am not professor material, and I'm okay with that. I'm really, I know, you feel differently. I'm really okay with that. But I got a chance to teach at Stevens Institute of Technology, my alma mater. And it was the class that I had to take 2 times. So I had to take it over, I took it 3 times because I took it at the academy, then I took it at Mines the first time, and then I took it at Stevens.
Oh, did you?
No, I took it at Mines the second time. I took the advanced portion at Stevens, and it's reinforced concrete. And I just had professors who weren't great at the academy, who didn't show me the easy process, who made it more difficult than it needed to be, and said things like, well, if you don't balance it, it'll fly off the page. And I'm a very literal person, and I didn't have the gusto to go after it on my own.
Sure.
Now, when I got the chance to teach this class, I actually thought it was just a concrete mix design class, to be honest with you.
Yeah, I thought
and then that's what it was. I was like, oh, mix design, I can totally teach that class in my sleep. So I found out it was a reinforced concrete class.
The entire semester.
I was a little nervous.
Yeah, you did great though.
And I spoke to our principal engineer, who was a professor at Colorado Denver, UCD, University of Colorado Denver, at Colorado School of Mines.
I want to say Metro. He worked at Metro too.
Anyway, he was a professor, and I said, David, what the heck do I do? And he said, well, John, you develop a course that you would want to take. Do it exactly how you would want to be taught.
That was pretty nice.
And I read, first of all, it was a great textbook that, you know, the person in charge of this class who came to us for help, she asked me if I liked the textbook, and it was the same author that I used.
Right.
And the one thing I remember is a great textbook, and I said, absolutely, love the textbook. And the great thing about the textbook is it gives you a flow chart to analyze and design, and the way that the author goes through, it's a Nawy textbook, N-A-W-Y, from Rutgers. You can't blame, from Rutgers. And don't judge him because he's from Jersey. It's a great place. Anyway, so he just has a way of getting you through the process in such a...
I know. So direct, no cloak and dagger. That's one thing
It's like breathing.
Yeah, that's one thing that drives me crazy is... Like, I'm going through...
This convoluted method that your author goes through. Oh, it's so stupid.
Yeah.
Like, and God bless these authors. They're trying to bring light to a very difficult thing, but the Nawy text...
It's just so direct, so intuitive.
Intuitive. Yeah. Like, single reinforced concrete beams. It uses the Whitney stress block.
We're a big fan of that.
Huge fan of that. And Whitney was going through it. She's like, I don't understand it. How do you do it? It seems like there's no rhyme or reason.
Yeah.
And now when you look at the single reinforced concrete beam design, it's simple.
Right.
I mean, you're balancing what's on the compression side and what's on the tension side. And you're using geometry and the material properties to create that balance. I mean, outside of that, I mean, that's... double reinforced, well, now you got to put some more steel on the compression side to take up, so you're not in that catastrophic compressive failure. And maybe when you start getting into T-beams or one-way slabs, two-way slabs, once you start getting into shear design, okay, a little more accountability, but all of it builds on each other. Punching shear, column shear, you know, the design, the footing design, all of it is supposed to be intuitive.
Right.
And when I designed that class, and David was instrumental in coming up with some of the theories, or illustrating the theories, but I just had such a good time. And, you know, I was teaching college students. And I know there was like one or two who appreciated it, who said something to me. But I know that every day that I approached that class, even if there were days that none of the students showed up. You remember that?
Yeah.
I still gave that class as if the students were in that room,
Right.
and they were paying for every freaking minute of being in that class.
Right.
I wanted them to walk away from that class thinking, I have something that can contribute to my career. I can get a job right now because I excelled in this class. And if they didn't understand it, I wanted to be there to help them piece it together. And I don't know if it was ever the best class that was given
Oh, I think
in my tenure, but
I think you were great.
I had an awesome time with that class, and I felt like, I mean, you're using those presentations right
totally.
now to get
Which is
through
incredibly
your
helpful. Yep.
reinforced concrete class. So I would say that was number 3. Number 3.
Yeah. What's been your favorite job that you've had in your concrete career? And you don't have to say this one, but like legitimately, what was like your absolute like most favorite thing that you've done?
It was a time and a place. It was right before the recession. It was a couple of years before the recession. I had been working for a company called Lafarge North America, and I was stationed in a research and development lab that had way too many toys for somebody with my passion to be allowed to use without any supervision. So I used to get into work at 3, 4 o'clock in the morning and stay till 6, 7 o'clock at night,
Right.
and come in on the weekends. You were there for some. And unfortunately, the people that I worked with, they weren't as excited about concrete as I was, so I had to make up fake customers who I had to create concrete mixes for.
Oh my gosh.
Well, that's where the practice mix design, there's 20 mixes in there, and I went and did the book design, went to my boss, asked him if it looked good, and he's like, yeah, it looks fine. And then I would go try it out in the lab and correct it, and then break the cylinders and whatnot. So anyway, this company I was working for, they noticed I had a certain passion, let's just say, for concrete. Sure. And there were 3 people in particular. DSP, 12 gauge, and JML. He was, so 12 gauge was the, what's it called, the Western U.S. Business Unit Manager.
Okay.
DSP was the regional director.
Right.
And JML, he was the French boss from Lafarge, from Lyon. And I was promoted to Crinolia Formulator. And my job was to bring a very specific set of chemicals and concrete mix that the Frenchies were using over to the U.S.
Right.
And the chemicals were cool, but the concrete concept, in a way, one of the quality control managers said, so you're making hard poop. What am I supposed to do with hard poop? So I had a couple sales folk who came up with this idea of getting a concrete that had a 90-minute slump retention and developed 3,000 plus or minus 500 psi, 2 hours from placement to open up the road for traffic, using the same concept and the same chemicals, but really just
Sure.
And I presented it to my French boss, and JML, I mean, he's one of the smart, if you're listening to this, JML, he's one of the smartest concrete people in the world, and he has no apologies for it. And I remember, we were going over paste volume, and he was instrumental in my career where I'm at now, because he pushed me to learn more and apply what I learned. I remember he called me up, we were discussing paste volume versus granular skeleton. He goes, oh, John, you make up a porosity index table, and then, I don't have a very good French. I feel like all French people have to do either a whistle or a farting sound. Or,
I don't feel like they do, generally.
So, I've been wrong enough. So we're sitting there, and he said, what you need to do is build a porosity index calculator. And he said, you know how to do that, right? And I said, yeah, of course I know how to develop a porosity index calculator. And it was a Friday night. He goes, good, I want to see your porosity index calculator Monday morning. And he was there.
Right.
With it. He had come in from Lyon.
Sure.
So I spent the entire weekend, and the calculator is literally, you're taking a pot of rocks, you're weighing it, it's the porosity index.
Uh-huh.
You do a dry rotted unit
Right.
weight, you're finding out the weight, you're basing that off of the theoretical weight,
Sure.
and you're just finding out the pore structure based on density.
Sure.
And it's so simple for me to say right now,
Because you
but I spent the entire weekend on Wikipedia.
trying to figure out what it was.
With the Neville textbook and trying to figure, and I finally did. He came in. He's like, so what? This took you 20 minutes, huh? And I was like, oh yeah, dude. It took me 20 flipping minutes.
Had a great weekend.
So working with him on that, first of all, he drank great wine.
Yeah.
Ate at
Awesome restaurants.
the Coral Room, $400 a pop sometimes.
Yeah.
But he was always into working your butt off in the lab to prove a concept. If you had an idea that you could put on paper, John Michel could create the concrete for it.
That's awesome.
And he had such drive and motivation that it was infectious. Like, you wanted to be as tough as he was. The first time I met him, I remember we're standing in front of this mixer, and I'm trying to guess. It said we're doing self-consolidated concrete, and I figured out a way to tell by the look of the mix in the mixer at the angle that it was what the spread of it would be. So John Michel and I are both standing at the mixer looking inside of it, and I'm trying to look as tough as he looks. And I said, hey John, or JML, what do you think the slump is, 26, 28? And he looks at me, he goes, don't talk about things you don't know, little boy. I wanted to kill him.
And then he wound up being a mentor.
Oh, he wound up being a teacher, a mentor, a coach,
Yeah.
funding source. He is a great dude.
Yeah.
Great dude.
Great.
So that was probably my best position as the Cornelius formulator, and that led to where I am today. So.
Thank you for sharing that.
No problem. Thanks for asking me those questions.
You are quite welcome.
It's time to go to bed.
Time to go to bed.
Hey, thanks for joining us. Don't forget to like and subscribe. Check out the Concrete Note, where we have our podcast where we talk about concrete that's neat from my head down to my feet.
We're reading. I think maybe you should read that article today that you were trying to read on the
The
video.
ultra small angled neutron scattering on the impact of nanosilica size and surface
For the
area
podcast.
of the calcium silicate hydrate molecular structure.
Not really camera worthy, but I think perhaps it could be a great podcast.
Thanks for joining us tonight.
Have a good one.
Go Concrete!
Beat asphalt.